Everyone. I'm Dr. Abhinaya Inbamani from University of Florida and FRC, Quincy. In the last session, we built a simple LED circuit in order to show when the soil was dry. Today, we will take it a step further. We are going to see how the circuits can become smarter, like how we can simulate the different soil moisture levels using a new component called potentiometer. Our goal is to see how the changing resistances can simulate the soil conditions, just like how the sensors read the real data in precision agriculture. Let's take a deeper look into the potentiometer, one of the most important component in a circuit. A potentiometer is a variable resistor. That means it can change the resistance based on how much you're going to rotate this knob or how much we slide this knob. It's going to have three different terminals, 1, 2, and 3. The outer legs, L1 and the L3, are connected to the two ends of the resistive strip inside the component. This particular strip is made of a material that resists the flow of current. It could be made of a carbon or a similar compound. For instance, if you are using a 20 kilo ohm resistor or a potentiometer, the resistance between the leg 1 and leg 3 will always be 20 kilo ohm only. The real magic happens at the middle leg called wiper. The wiper is a movable contact that slides along the resistive track when you rotate the shaft or turn the dial of the potentiometer. The panel mount pot is used for the manual adjustments. The trim pot is used for the circuit boards. And the third one represents the functional diagram showing the wiper movements on the resistive path. And the fourth diagram is the schematic symbol which we use in the circuit diagrams. So this is how a potentiometer works. In real time, we use potentiometers in many places for adjusting the volume in speakers, for adjusting the brightness in lights, and in our case, it's simulating the soil moisture levels. Let's start to design a circuit. Go to the browser and type tinkercad.com. I will pause then and there so that you can do it along with me. Click sign up to create a personal account and then try to sign in with Google. Once you are in, click create circuits. Now, use the search bar option in order to find and drag the required components onto your workspace. So the first important component what we need is the potentiometer. Bring it to your workspace. You can see the potentiometer has three terminals, terminal 1, middle pin, and the terminal 2. When you turn this knob, the resistance changes just like changing the soil wetness level. Before connecting our potentiometer to the circuit, let's connect it with the multimeter. Multimeter is a very handy tool used by the scientists and engineers in order to measure the electrical quantities. The full name multimeter comes from multi, meaning many, and meter, meaning measure. So, as the name suggests, it's a multi-purpose measuring instrument which can measure the voltage in volts, current in amperes, and resistance in ohm. There are two types of multimeters, analog and digital. In our simulation, we will be using the digital multimeter, which displays the readings clearly on the screen. Now let's connect the multimeter to the potentiometer to see how the voltage changes as we rotate the knob. As a part of first experiment, let's connect the negative to terminal 2 and the positive to the terminal 1. You can see the maximum value of this potentiometer. The maximum value of this potentiometer is 250 kilo ohm. Though I change my knob, I'm not able to see any changes in the resistance value. The reason is because I haven't given any connection to my wiper. Now it's time to give the connection to the wiper. You can remove either of these connections and connect it with the wiper. Once it is done, click Start Simulation. You can see the change in resistance value. This happens because the potentiometer divides the total voltage across the resistive path. The wiper is going to pick up a point between the two ends, and that's why you can see even the voltage keeps changing. In simple terms, the multimeter helps us to see what's happening inside the circuit. It's going to convert the invisible electric changes into numbers, which we can read and understand. Now, let's bring in the other components we used before. Let's try to bring the breadboard onto your screen. The breadboard is needed because it's going to connect all the components. Try to bring a light emitting diode onto your screen. Bring a resistor onto your workspace. This is going to protect the LED from the excess current. Then we need a 9-volt battery, which is going to act like a power source. Arrange them neatly in your workspace before wiring. Now, let's start connecting our circuit step by step. Insert the potentiometer across the middle range of the breadboard. This keeps all the three legs in separate rows so we can connect them easily. The red wire from the battery is the positive terminal and connected to the red rail of the breadboard. You can give a different colors to the jumper wires for better understanding. The black wire is the negative terminal and it connects to the blue rail or the negative rail of the breadboard. Connect the outer pin of the potentiometer to the positive rail. Connect the other outer pin of the potentiometer to the negative rail. The middle pin of the wiper gives the variable output, and this is the pin that's going to change the voltage as you rotate the knob. So connect the middle pin of the potentiometer to one end of the resistor. Connect the other end of the resistor to the anode of the LED. Connect the cathode or the shorter leg of the LED to the negative rail. With this, all the connections are done. Now it's time to give start simulation. Slowly turn the potentiometer knob. You will see the LED brightness is changing. It glows brightly when resistance is low and becomes dimmer when resistance is high. Try giving an appropriate value of the fixed resistance to get the proper output. You will see the LED brightness is changing. It glows brightly when resistance is low and becomes dimmer when the resistance is high. So this simple behavior has mimicked what happened in the field. When the soil becomes dry, the resistance increases, just like when you turn the knob to a higher resistance. Why does the LED brightness changes? It's all because of the Ohm's law. V is equal to I multiplied by R. So when the resistance increase, current decrease and the LED becomes dim. This is exactly how the real sensors behave. They convert the physical changes like soil moisture into an electrical signals that the systems can read. You have just learned how to build a simple circuit which can sense and respond to a change. Key idea behind every smart farming device. Try giving a name for your circuit. The main advantage of using the Tinkercad is all your circuits are saved automatically. You can share it with your teacher or your friends using the send to option. Thank you for watching this session. I hope you found it useful and enjoyed learning something new today. See you all in the next session. Until then, happy learning and keep exploring science with technology.